Hello, good morning to all. In this series, we are looking for the interface protocols. So there are lots of protocols for the communication between the host and the slave, like I2C, then SPI, then AX also is there, then I2S, then UART. In this series, actually, we are trying to get all the uh, information as well as the code for the interface protocols. Interface protocol, it is kind of regressive signaling understanding actually. So in any protocol, we have to understand what master is sending and what slave is receiving. So it is ultimately interface signaling understanding between the host and the slave. So we are trying to start with this LLM Lattice Memory Mapped Interface protocol understanding with the some signaling interface and the what interface signals we have for the LMMI interface. So we start with some basic interface diagram. Let's say this is master, this is slave, and both are having the clock and reset explicitly. We are in this diagram. I'm not showing that, but what master sending and what slave is receiving, they are just read write. Then offset is nothing but the address, write data, read data, valid, read ready signals. So basically, if you're looking to the this diagram, it is a little bit relevant to the any memory read or write, or basically it is a memory read write signal alignments there. So the request, read write, offset is nothing but address. This upper green signals are coming to the slave devices, and the red colors signals getting out from the slave devices. It is very simple. We have to place the address on the offset. If you want to write the data, we have to place the right data, and we have to make sure that it is a right. So WR RDN kept to be 1, and we have to place the request signal. So, and it just memory write signaling. Similarly, we have, if you want to read some data from the slave, we have to provide the offset like here. We have to uh, place the request, but before that we have to place the RD bar, means we have to keep this WR RD signal to be low and place the request. So in this LLM interface, everything is in one clock transactions. So it is very good to have these kind of things. So we begin with the signaling of the LLM. So this clock and reset is a very common thing that both slave and host will be there having the same signals. As I told, that request is the input to this to start the transaction. WR RD is nothing but the read write. If it is 1, it is write. It is 0, it is read. Offset is nothing but the address. W data means host need to be place that data to write into the slave. Similarly, these are the related to the read signals. Read data out is slave place the R data and place the valid signal to host, so that the host can get the data from that RD data. So the simple flowchart is like that. We start with the new transaction, and it should be start with the request equal to 1. We have to place the offset means address. what kind of read or write operations and w data if we are writing the data. If slave is ready, so the process started, and if it is wr equal to 0 means we have to read the data from the slave. So these are the transactions for the read process, and these are the write transaction. So there is a one signal is called valid signal or ready signals. Valid signal, if it is 0, we have to wait until the slave is ready to get the data, and if we are writing to the slave, so slave should be ready to accept the data. So once the ready equal to 1, the host can write the data. This is simple as master signaling the slave devices. So we can begin with the waveforms, simple waveforms. First with the write transaction. After this LM, this is a what happened. We have to place the offset, means address. Master place the address, then data. Then we have to inform it is the write operation, so WR equal to 1, and we have to place the request. So this is a simple one clock transaction is happening there. Okay. So in next slide, if the slave is not ready, means if we are, it is similar waveforms but with wait states. If the slave is taking time to get the data, so the slave place the ready signal to be low. So in that period, master cannot write anything on that because ready is not. So next is on consecutive data to be write. So in that case, we assume that the slave is ready always. Okay, so we have to place the data. It is similar. It is one transaction, second transaction, and third transaction with the write signal, request signal continuously, addresses increment or anything like that, whatever it may be. So on the every clock we have the transaction. These are not required while writing the data. This kind of process is called the burst writing process. Burst write with the wait state. Let's say after one transaction, the slave is not ready for the another data, so the slave kept the ready signal low. Once it is ready, the next data will be transact. Again it is in read transaction, everything is to be same, but it is to be low, write signal to be low. We have to place the address, there will be the request, and obvious ready signal will be 1. So slave received the address and sense that the master needs some data from this location. It's happening in the T1, and once it is known, master requests the data, so the slave places the data along with the valid signal, so that in next clock it will be completed. It is like the memory thing, like we have to place the address, request for the data, and obvious the memory will send the data on the next clock. It is like that. Wait state here. In next block, what in next waveform, what we have seen here, it is same waveform, but at this stage, once the address get latch into the slave device takes some time for that to release the data. It might be happen that it has to be read from somewhere and then put on that bus. So in that duration, the slave put the wait state here, and after some while, when there is a readiness of the data, it would put on the data bus and place the valid signal. So it is the same thing that we have seen earlier. Sometime what happened, there will be the consecutive read process from the slave. So continuously address will be placed on the offset, and the consecutively data coming from the slave as well. Okay, so sometime what happen, the burst read will be happen like this is one transaction, and for the second data, uh, this is a request for the read data, and the to get that data from this offset, slave needs some time. So this is the time it will take, and it will place the data corresponding to this offset. And when master required another data from the offset 2, again it will go back to the wait state, and once it is ready data 2, it will acknowledge with the valid signal. This is very simple protocol. It is a back-to-back read and write. This is for read operation because it is low, and it will place corresponding data, and this is the write operation, so it is going to be write into the slave device. So this half part is read, half part is write, but for the reading process slave takes some time. It will obviously send in data into clock 2. Request in clock 1, it is sending data on clock 2. Slides, it is for read, this is for write. We have to place the addresses. If the address is not present, if the data is not present for this corresponding address, slave goes to the wait state. Once it is ready, it will give the data. Again, once it is ready, another request is put on. Once it is again get the request, it again goes to the wait state, and after some while it will give data like that. Similar, you can refer the detailed document on this efficient memory map address data interface. I am referring to this document. You can also refer for the more details. From the waveforms, it seems to be it is very simple memory mapped address data interface. Register memory access, both single burst transactions can be happen with this single clock transaction, so it is a very fast, but one clock is very important there. Also the wait state can be incorporated if the slave taking time to acknowledge with the regarding the read operations or write operations. Pipelining transaction can be possible. Flexible implementation, single and burst, simple transaction, single transaction, burst transaction, and pipeline transaction we already seen in waveform. Out of order transaction is not supported with the LLM right now. So this is a very vendor based interface. Why we are using it is simple through high throughputs. So I hope it is useful for you to have that signal information to start the coding of the LLM interface. So in next part we will start simple read write LLM interface with respect to this slave. Thank you for the implementation of the LLM interface. In the second part we start with the coding of LLM interface. Thank you, and please subscribe my channel and support me. Thank you.